Thank you. All right, so a couple disclaimers. These lights are really bright, and I'm not used to that, so you're going to see me do this a lot because I'm not going to wear sunglasses. At dinner, we were talking a little bit about who all is in the audience, so I'm going to just kind of say a lot of this is going to be focused towards the industrial design side. A lot of it's going to be focused towards making product real. I hope that there's an ability for that to translate across everything and all the different disciplines that are in here, because at the end of the day, making something is making something. It's pretty much the same. The purpose is going to change other pieces. So if you have any questions or if you have anything where you want to talk about it along the way, I definitely want to open this up. Let me know. Let's have that. This is not a one-way conversation, so please ask questions along the way. Don't wait to the end. All right, so the focus of tonight's deck, or tonight's presentation, is really the design is done, now what? And what I've really learned, I'll talk a little bit about myself and the road that I've taken, but I've really learned in the last 3.5 years what it means to actually finish design, where that line draws, and then all the effort that happens after that to actually turn it into a product, to actually make it something that can go onto a customer's hands, go into their hands, go onto a customer's, onto the shelf for what we call activation, right? I mean, so we'll go through this journey a little bit. Ultimately, we're going to be navigating the path from requirements. So that's hopefully what happens before design. Somebody thinks about the requirements and the design to scaled manufacturing. And the first half of this deck is going to be kind of like setting some foundations of like, there's a lot of different ways to do this. The way that I'm going to talk about it is the way that I like to do it and the way that we do it where I'm at now at PCH Lambda. Because we focus on that word scaled manufacturing, it implies a certain level of rigor. It applies a certain level of expectation from the customers. It expects the level of quality and fidelity to be what you expect when you're spending $1,000 on a cell phone, right? I mean, like that sets the bar very high. How do you translate that to a $29 whatever or $150 trimmer for your hair? That's what we focus on, is bringing that fidelity all the way through. So another foundation part, the design of hardware is, maybe I'll stand over here, sorry, it's like really, you guys got to work on this.
I think that's for the camera. So
is it? All right, and I'm just ruining that by just babbling. All right.
Do you want us to adjust it?
No, thank you, thank you. You guys will edit that out. Another foundation piece is that hardware is difficult, and there's a lot of jokes about that's why it's called hardware. And all those aside, it really truly is. And a big foundation of why it's so difficult is it has to happen in series. Like when you break it down, you have to solve one problem at a time and cross one bridge at a time. In software and in many other ways, you can start to solve problems in parallel, and you can start to have integration happen through communication, through repositories coming together, through APIs, linking pieces of software. So you can have large teams working together in parallel and create that integration later in time as a different point. In hardware, you can't solve texture problems in the tool. You can't solve part line tools until you start making parts. So you have to cut steel. Once you start cutting steel, you're investing a lot of time and a lot of money. So you're drying plastic, you're getting the injection temperatures right. It's just a long series of product steps of process that you can't shortcut, you can't run in parallel, and the investment tends to be a lot higher. Last time I was here, so it's my third time. Thank you all for having me back again. The first time I talked about design's purpose is to be meaningful. Our job is to bring meaning to products, right? A lot of people can design, I'm not gonna say anybody, but a lot of people can design products, and we know which ones are solving a problem, which ones are meaningful, the ones that we really want and crave, and the ones that are just out there. And our job to be good designers is to ensure that the meaning is appropriate. So that applies to this part too. But we'll go through all the different steps to make it a product. A little bit about me. The production chain is going to be a bit of that foundation we talked about. The design values will be a foundation, and then why my foundation's a little bit different on that. And then we'll get into the meat of what we're talking about tonight. DE is design engineering. We'll go through that definition, the new product introduction process. And I added some slides around manufacturing models because I think it's important for design to know about it, to really own it and go all that deep into the manufacturing and embrace that early on as what I'm calling the bridge, is really connecting design to the end. If you assume the wrong manufacturing model, you're assuming in your design a process that might not be right. And how can you control that from the very start? And then the cost. There's a couple of slides to just open up that door of, as we deliver this for customers, and this becomes real when you're shipping 1 million of something, what does the cost really look like? And when your customer sees, when our customers tell us to drive down a cost, $3 on a $43 BOM, you'll see the math of what that actually does at scale, and how all of a sudden a company has another $500,000 to invest into marketing, into sales, to sell more product. The outcome is some photography, some photos of some cool work. I didn't want to present to you all without showing some cool work, because we've got some cool work in our portfolio. So I want to get to that part because that's fun for me. And then the conclusion is really just wrapping that up, but I want to really ask questions at the end. Let's talk about some of these things. So thank you for starting out about me, a little bit more about me and some pictures. I graduated here in '96, went to go work for Teague as an industrial designer, got to work on planes, trains, and automobiles, was not part of the aircraft group. Really fun work. I learned a lot. I was asked this morning or this afternoon in the class about foundation leaving here. I actually really truly felt prepared to go out there. I really truly felt I knew how to be humble with a skill set that was refined enough to be impactful. And that was a big jump for me to go to a firm like Teague, working with some really experienced, top-tiered, old-school designers. After that, a company called Pivot, where we took a lot of the clients and the same work forward, kept working on it, moved into a couple of other pieces, but it was really focused on sports equipment, treadmills, bikes. We did a lot of in-flight entertainment, so as you jump into airplanes, Airbus A380, we worked on a lot of the if you ever buy one, the base aircraft interior, worked on that with Airbus. And then somewhere along the way, I went and got an MBA. And in 2003, I moved up to the Bay Area and became creative director from one office and eventually 2 offices for Frog Design. We'll show some pictures of some of the work that really started there in the next couple of slides. I moved into a GM role, which was part of mixing together the industrial design background from here and the MBA background. This is where it really starts to come together for me as my career takes that real turn to, okay, now we're doing what we teed up. VP was for me a role of building new businesses, building new offices. I traveled the planet a lot, building offices in in Seattle, Shenzhen, Amsterdam, Munich, just really growing the portfolio from 6 to 9 studios in the course of a couple of years, including hiring people, building the business plan, getting the funding in place, meeting with the cities on where to rent the space. In 2014, I left. We talked a little bit about that today as well. Frog took a turn a little bit, and that turn and my career paths kind of started to part. And I bumped into the guys at Lime Lab. We've since rebranded it to PCH Lime Lab to tie better to our parent company. We make stuff. So we have 0 industrial designers on staff, except we have 0 graphic designers, 0 digital designers. We rely on partners of all the top tier firms around the planet to do that for us. So we hire them, we bring them in for our clients directly. It allows us to have access to world-class design talent that's specific to what we need when we need it without, are you yawning for real? Without actually needing to hire the people that we need to bring in for ourselves. So we don't have to compete with the talent base. The engineering staff that we have, though, is world-class. It is absolutely the best staff. They all have backgrounds and experience of actually shipping product. Everybody likes to see the brands that you've worked on, so I'll throw that up. Going to the pictures, though, right after I started at Frog, got to work on landscape forms. And I show this one first because most of my life now deals with bits on a board. It deals with a display. It deals with battery life. It deals with Wi-Fi and all that. None of that. A roto-molded chase lounge. And this whole client was a dream to work for, absolutely amazing. It was all about beauty, style, and durability in a public space. Did a lot of work for Logitech, including what we called the lipstick cam, and there was just a bunch of other pieces that went through this and got to be a big part of shaping that years ago. In the server room, got to be a big part of designing what you don't see in the patching and the connectability and the connections in the back of the server room. Did a lot of stuff with Disney on many different bands and different levels. The Magic Band, you've probably had a couple of other people walk through here presenting this because a lot of us worked on this. And this was from user experience all the way through to designing the bands at 2 different sizes. And it lets you really take your relationship with Disney with you. It lets you assign that relationship to your children so they only have so much money for an allowance. Really took the experience in the park to the next level, and it manifested itself through the touch points and the bracelets. And again, this was a huge team. We probably had 15, 20 people in each studio working on this project around the board. It was a big one for us. Air conditioning units for the outside, hard drives for the inside. The last 3 years, I've been really focusing on realizing ID. So this is make it real. The biggest learning I have and what I hope to share today is how hard that really is. As designers, when you're done, you've got the small sliver up front that gets to be, I mean, honestly, it's the most fun by far. But after that, it's definitely a lot of work. And when you start to see the scale of the impact that your decisions make, truthfully, you are given, there's a deficit. They have so much more time to erode the fidelity of your design. So if you don't go in owning it from the very beginning, by knowing what the hurdles are, you cannot manipulate it up front. And that's the biggest part I really want to share with you, and I'm just going to say the word so there's no missing it. I hope that you understand this and go and learn more about it so that as you're in the world and you need to ship product, you're guiding your customers, your projects, your work, and you're setting them up for the design that you planted, and you're not giving it opportunities to be eroded just because somebody doesn't know how to inject plastic with a pull that goes that way. Like, no, it's not acceptable. You get to own that from the start. Yes, up front. 100%. Like that's what I mean by your fidelity making it to the store shelf.
And theirs is going to be ugly.
They're going to have different, I can't say that because it'll get back. No, they're going to have a different lens and they're going to have a different purpose. They're going to bring a different value proposition. And if we understand them as designers in the very beginning, we can design with that in our recipe. It's a toolkit, it's not a hurdle. And if we bring that up front, our design will embrace it and it will get through the process with what you designed. And that's the value proposition that you're going to be bringing to that. So another part of the foundation is the production chain. And it looks really simple when you map it out in what actually happens. So designers are going to live up on the left and truthfully put FedEx, UPS, what we call 3PLs, third-party logistics, are going to live over here past the transport part. After design, you go into the engineering, you go into new product introduction, mass production, where you start to get into how do you sustain a factory, how do you keep it going. I mean, like down to the level of what type of lighting they need to think about. We're not going to get into that. But final testing, final assembly, all the different protocols to make sure that you're actually thinking about how is this going to be tested when it's done. And export, transport. This one right here of regionalization and postponement, when I went to school, when we were here, we always talked about being able to customize things super late. And you kind of think it happens over here in making something. But it really actually happens after you make a bunch of parts, and then how do you customize them? And this was a big learning, seeing this on the floor, seeing the ability to postpone or late stage postpone and fulfill something, make it custom to what you're trying to do. This was a big learning for me to see that postponement, serialization happens so late in the process, but when you see it on the floor, it does make total sense. And then export, thinking through the boxes. I mean, working with packaging designers on how is it going to be shipped out. We did a music player for Neil Young, the Pono music player, and it was shipped in a bamboo box, packaging, beautiful bamboo box. We were fulfilling them one at a time, so they were custom flashed for the music that you wanted, signatures laser etched on the back. They were amazing. Put into this beautiful bamboo box and shipped off. We sell to our clients a 3-day turn anywhere on the planet. Turns out that bamboo as a natural product needs to go through a quarantine. It takes about 4 weeks. Normally you quarantine an entire 52-foot container and you're all done and you can ship a 52-foot container. But when you ship them one at a time, people had to wait 4 weeks for each little box. It's one of those lessons learned of next time we're going to quarantine them and we're going to do final pack out in the States or in the final, the country of past quarantine. You just start to think like the design will not sacrifice. But now that you know that, you can start to think around it and you can start to plan, how do I solve that? You end up making your bamboo boxes early, you ship them to some other place, and you do the final pack out somewhere else. You eliminate the quarantine as a time lag and you figure out how to get it in there faster. So the reality is, this is all the stuff that happens after the design, and these boxes up here are the supply chain. They're not connected. We're a company that we work hard to connect them. Nothing's ever perfect. We've got 1,200 different partners in our supply chain base, working with 200 to 300 at any one time actively. That's manufacturers that are doing plastic injection molded parts, they're doing circuit boards, they're doing component sourcing, they're doing the lead, they're doing the other sourcing for the feeds and the leads on the boards. They are everything that you can imagine on that bill of material somewhere fits into this supply chain. And the reality is it's disconnected from design, and you'll see that it's physically disconnected. Like, it just doesn't make that way. This is the part that we need to work on. This is the part that we're going to talk about bridging, because if we as designers can think in this area, we don't need to think down here. We don't need to worry about that. But if we can start here, they start to overlap and we start to own it. We start to lead that and we feed it all the way through. Again, ensuring that the fidelity. So this is how the bridge kind of walks through, it works out. And I'm going to talk about these two areas tonight. All right, we're going to shift to the next foundation, design values. I hope I don't ruffle feathers, but I do not believe that all design is equal. I believe that there is good design and there is bad design. And I've chosen some selections very creative to make sure that I'm making that point. And when you start to see wires hanging out, when you start to see a commercial applique of some sort stuck onto a version that's supposed to go into a kitchen, I start to have cringes and I start to have real problems of, this is not how design's supposed to work. Somebody is leading this with a different lens. So not all design is equal. But the purpose of your design will drive the manufacturing values. That's what we need to start focusing on. And customers will respond to that product. They really, truly will. When you look at the top line, we'll talk about costs later. We'll talk about some finance pieces later. Android phones, it's an operating system operating on a bunch of different handsets versus iOS on purely the Apple phones. Apple is generating and charging 2.7 times the value of the handset. So their phones are over 2.5 times as expensive, and it's not just the glass and the metal and the bits, right? It's the overall experience. But that is truly good design going through the whole product, creating an amazing value proposition. Secondly, I don't believe that all manufacturing is equal. Before we get into the now what, but we have to think about capacity. We have to think about capabilities. We have to think about what values the product, the brand, the customer needs, and align the factory to line with that. These are real photos from our team. The top one is a project that we are wrapping up right now, and we had to pull the customer out of that factory, making cosmetically beautiful, non-painted plastic parts. That was their tool storage. Down below is not where we put them. This is a super ideal. This is literally the other end of the spectrum. That is a computer robot-based system for collecting tools and bringing them back to the factory floor. You really see the difference of what's valued, right? Like, what do you really care about? When you see the EDM machines and you see that, you've got trash all over the floor, we've got some other mill over here, who knows if there's anything in that tank even, you see the opposite of it. And that's the same factory, so we pulled them out of that top factory 100%. And then the molding machines, molding machines, we're not going to look at how new they are, how old they are, but when you start to look about how do you treat the product, when you look at these have conveyors that come out, they go into a bin for collection. Up there, I don't know. Like you really see that they're not valuing the product. This is how we look at factories. This is what we bring. And as you get into the career as an industrial designer, I can't stress enough, get to a factory. They exist in the United States. We moved all of this to the United States, being made in Fremont, California. So this stuff, you don't have to go to China anymore. A lot of this exists here. It's quite a bit of it actually in Southern California as well. So I really recommend somewhere getting out there and looking at some of this and seeing some of this. Hopefully you'll see the bottom. So in that manufacturing, the brands are going to drive that value all the way through to the factory floor. The market is going to respond to that. So I'm kind of really trying to instill this part of like the value goes all the way through. So about me, I'd like to share a little bit about what do I focus on. I focus on companies and work and projects that are passionate about design, the customer experience, and their brand. In that order though. And the reason this is important to document and to really talk about, and we do this as a company, it's in me too, this is what I've always focused on. But when you have this as a foundation from the beginning with your clients, your manufacturing partners, and everyone shares that, when the hurdles happen, when the hurdles come, this is what's going to get you through it. You're not going to solve it and get through it because of a radius or because of something else you can't solve. You're going to solve it because people have passion to fix it, and their passion is aligned with the right reasons. The decision making that goes behind this will all be driven back again to the values that are important. Okay? So I have peppered in some examples along the way. This is a project that we did for a shower head company based in the Bay Area. It's called Nebbia. And we did a lot of prototyping. And we'll talk about the engineering build cycles of how that happens and why that happens. In our lab, we have a 10,000 square foot. It's not huge, but it's extremely packed in with 3 different sizes of CNCs. We've got a 5-axis CNC. We've got the hand lab. We've got dedicated 5-person crew that runs the machine shop. 3D printers at our disposal. I mean, it's all the stuff that should be expected in a design engineering in a proper firm. But our team is dedicated. Our team is using it all the time. We took out one of our showers. We have a bike room with 2 showers. We took out a shower there, and we actually made it a prototyping center right there. So we were doing this in our building, people taking showers with us. All the client had was the nozzle technology, and what it does is it removes or reduces water consumption by 70%. Then they had this great sketch of this design by Box Clever Design, and they wanted an Apple-esque feel. I'm not going to use that adjective too much. I hear it a lot, but as you move a monitor on the Apples, that beautiful clutch feel that you have as it rotates, as you open and close the laptop, there's a certain beauty to that function, to that operation. They wanted that in a horizontal motion as you slid it up and down, because that shower head is atomizing the water, and if it's more than 3 inches from your head, the water gets cold. So if you're showering in the same shower as someone else who might not be exactly 6'3", they're 6 foot, it's going to be freezing cold. So we had to create super simple to install and easy to adjust with a beautiful feel. Had nothing to do with the design, right? I mean, nothing to do with it. We got this into manufacturing in less than 12 months. It's being made in Minnesota right now. And a big litmus test of manufacturing is this thing called yield. How many products make it through the manufacturing cycle, through the process, to be able to ship to a customer? The higher the number, the better. First 9,000 units made, 46 failures. And that's pure and simple. The engineering team that did the work on this, they nailed everything. A large portion of those were due to them changing the robot for the glue. Not our problem. Pretty cool. We're really proud about that one. Okay. Any questions? We're going to jump into a little bit more of the meat now, the design engineering. I think I've set the foundations. You guys know what I care about. You know what I believe. Now we'll figure out how we do it. Any questions? Too easy. All right. So, some definitions. Dave warned me about my use of acronyms at dinner. So, design engineering, I'm going to read a little bit of this, though, is the methodical series of steps used in creating functional products and processes for the purpose of commercialization at scale. And those last three words are a really big deal of how and why design engineering is different from product design engineering. And product design engineering is definitely has its place. This is just that slight little twist, slightly different. It's highly iterative, meaning lots and lots of cycles of failing very quickly. But in the end, it's a unique custom product. We'll talk about the manufacturing types of manufacturing facilities a little bit later. And you start to see uniqueness is tough for a lot of factories to do. A lot of factories don't want to do something they haven't done before. We as a company pride ourselves on solving design problems with design engineers and manufacturing problems with manufacturing engineers. So by keeping it in its silo, we keep the fidelity high. New product introduction is a series of clearly defined, and we're going to go through them step by step, and ridiculously often confused. People will slip these things back and forth and think that you can do 2 or 3 engineering builds, validation builds. You're not supposed to. You need a couple, but confusion on these is a really big deal. And these stage gates happen in series again. You can't skip these. You can't do them in parallel. All right? So this is kind of what that looks like mapped out. On the left, that is not the design of the industrial design. The industrial design is all going to happen before this, as does the marketing requirements doc, the product requirements doc, manufacturing specifications of some sort. Ideally, a CMF is done already. Ideally, at the end, you have budgets all the way through to MSRP. And these become guiding functional pieces for the rest of the process above, right? So as that industrial design is done, we're going to go through these steps to kind of quantify it. We'll talk about it in detail. And then as you develop it, those are the engineering cycles to really build, fail, 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 and eliminate risk one step at a time. The manufacturing processes have clearly defined stage gates, and you don't sign off on them until they're done, until you're ready to move to the next one. We are not going to talk about manufacturing sustaining. You're really getting in there to scaling that final number 7 and repeating that over and over again. So we're not going to get into that. We can talk afterwards if you have any questions. We have a separate business unit that's what they do for us completely. And long-term clients, I mean, we serviced Apple for 13 years. We serviced GoPro for many years. Countless number of brands that were secretly behind the screens, behind the scenes shipping to you all regularly. All right, so we're going to jump in line by line through these different phases. And the design part is about clarifying the project, clarifying the concept. What are you trying to solve? In the define stage, we are, do I actually go into that? Yeah. In the define stage, we're capturing the problem. And this is not the same problem that the industrial designers did. This is not the same problem. That was about usability. That was about user experience. This is now, what are you doing? How are you solving that? What were you thinking? How do we as the engineering team capture that problem at hand and start to think about the work streams to eliminate all that risk? And then the explore phase. This is very similar to ideation in the design side, in the industrial design side, of thinking of different ways to solve those problems. This is where there is a lot of overlap, but this is engineering. A key part here is to bring in this thing called design for manufacturing, design for assembly, design for X, anything else. We bring that all the way up. It's a bit of a competitive advantage because we're connected to so many factories. It's a key to have tooling, manufacturing, et cetera, engineers up front. As you're exploring, as you're ideating through these solutions, they will start helping the designers, the engineers help us start thinking through to the architecture. And at the end of architecture, just like an architect would have, we have a set of blueprints of where we're going. What we don't have is a design build set of drawings, right? It's not engineered yet, but it is truly, this is the design that we're going to build, this is how we're going to go. Usually at that point, it's existing in slides, it's existing in drawings of some sort, some rough 3D CAD. It might exist in some breadboards that are on a table that are not ready for manufacturing at this point. But at the end of architect, we're ready to start telling the client exactly how we're going to build something. So we've defined the path, the requirements are nailed down, they are buttoned up. Any changes that happen after architecture in our world become change orders, right? You've really changed the product in some way, so everything after that needs to be adapted to that new piece. We're alignment across the disciplines, and what I mean here is electrical engineering, firmware engineering, mechanical engineering, RF, getting everyone, and I'm not going to read through this, but I threw all these acronyms and things in there to just throw out, these are all the different documents that are being created. These are all the different steps that need to be controlled. I can just send this to you, Dave. You don't have to copy it, don't worry about it. This list is actually quite a bit longer. I pulled out the ones that I thought were the bigger ones. When you start to get into test plans, when you start to get into things that we as industrial designers don't always think about because we want to design the product, again, bringing that forward is critical. I'm personally very focused at this point on getting the bill of materials and the cost of goods sold. And we'll talk about the difference between those two a little bit later. The bill of materials is basically the price for a bag of parts. Cost of goods sold is for the product that the brand is buying from a manufacturer. Now they have to go package it, they have to go sell it. So there's other steps along the way, but those two numbers are important in our world as customers start to think about how am I going to make it, what do the components base costs, what do the materials cost, et cetera, through to what quality do I want for quality control. So the difference between those two, BOM and COGS, you start to have assembly, you start to have labor in there. And these pieces start to tell us as the engineering team, are they really on board for something to be done beautifully and being done very well? So the timeline is the last part of each of these different segments. And if anyone in here, if there's anyone that has shipped hardware, this is the one where everyone in the beginning says, oh, it never takes that long. And then in the end, people will, well, wait a minute. Yeah, no, it really does. Being honest and being open with people up front of how long this takes is how you do it right also. Shoving this to do it too fast just cuts corners at the end of the day. So we'll talk a little bit now. Any questions on design? We're going to kind of go through these phases this way. Okay. So develop is how do we convert that architecture to an actual solution. This is the core of the mechanical work. It's graphically misrepresented. It is very long. This is months and months of work. And we end up calling them EB1, EB2, EB3, or B1, B2, B3. And these engineering builds at every single stage with successive builds get closer to the final product and eliminate risks in a logical planned pattern. So we're maturing the design, we're testing the design at every single stage. So in the first one, if you're doing a drone, you might want to make sure that you are ensuring that the propellers are spinning right, that you can carry airtime, but you're not worried about battery life at this time. You're not worried about does the battery stay in. You're not worried about can you ship it with a battery loaded or not. You're worrying about individual sections and individual portions at each time, and every time you do it, you're maturing that along the way. Does that make sense? So we engineer to fail quickly. Everything is based on clear work streams and test plans. You build the test plan, you engineer to eliminate risk, you test it, you take your data and you go back and you do it again and again and again. And at the end, this is eliminating risk. This is the big part of doing things for scale, happens right here. If you take away the words manufacturing for scale and you're just going to manufacture and you take that word off, you're not eliminating risk. You're finding a way to do it, and it could be the perfect way. I'm not discrediting that at all. But you cannot tell the customer, you can't tell the client at the end that we have eliminated risk. You can say we found a way to do it. And it's a very philosophical difference, I get it. But at scale, that drives yield. At scale, that drives customer support and customer service. It drives returns. It drives all these other parts after the design is done. So some of the key outputs on this one, again, solving the problems one at a time. We end up having a full EE package. And this is ready to go to tooling. The EE Gerber is just a fancy word for a repository for what's going to go onto the EE board. And then you've got the architecture layout for that. Firmware repository is ready to go and is being tested for load. It's being tested for, is it going to survive the shipment? Is it going to survive when it gets to your doorstep? Are you going to have to do an over-the-air update when it lands at your doorstep and Christmas morning crashing every Microsoft Xbox, right? I mean, this is where you start to think about those failure points. And another list of all the different stuff, and there's a ton more that goes after this. All right. Timeline on this one gets pretty long, 8 months, and really complex like a drone. It will literally be 8 months. Something as simple, we did a flipping phone case for augmented reality on the back of a phone, completely mechanical only, and it was still 3 months to get through this. So as you're adapting to different phones and you want to use the same lenses, the same flipping mechanism, it gets pretty tricky. Something seems so simple. All right. Any questions on that? You guys are making this easy. All right, so NPI, the new product introduction, and the manufacturing validation, this is where we now have to prove reliability. So up before this, we've designed for that. Now we're going to have to prove it. We're going to go through a series of very defined tests, where before it was defined around work streams, risk elimination. Now we're going to go around very key pieces of, initially it's cut the steel, but EVT is, how can I make one of these with the engineers that designed it off of factory tooling? Then the next one, DVT, is how can I stitch together factory tooling and inject automation? How can I inject other processes so that I'm eliminating the engineer that designed it from the process? And then lastly, PVT is scaling that. We'll go through those in some detail. So acronym release here, EVT is engineering validation test. We have a design validation test and a production validation test. EVT. Can we build several units that perform well? Well, they don't have to perform perfect. They have to perform well, but function exactly as needed. I think we'll have some pictures at the end of each of these, and you'll kind of see through an example of the drone itself what we're talking about. But we're releasing for tooling, we're injection molding, we're building first parts, we're bringing up the boards, we're flashing them, we're doing all the tests, we're stitching it together. At the end, we're going to have 50 to 100 units to really start going through the cycles and the tests for certification. Non-production processes, non-production processes, but we're having production tooling, we're having production parts built. Activities in this phase are going to be the reliability tests. We're going to start doing FCC testing on that. We're going to do firmware debugging on the actual product itself. The first builds start to design the production jig. So we start to now have the real thing that we're going to hold. How do we work through that? And what it kind of looks like is, you'll see here, I didn't put in another picture, I'll have some arrows. So there's no texture. It's absolutely shiny all the way through. When we get to one of the other phases, you'll start to see some pictures of blemishes that we don't worry about, and when we start to worry about them. There's a huge amount of part gap happening right here as the top and the bottom are coming together. So how do you modify the tool to get that to sync exactly the way you want it to go? The legs on this one, we're not popping in exactly. So when you design in CAD and when you design and you think about all the pieces and you prototype in 3D, it's not real until you're injecting that plastic. This is the first time you get to hold what you really design. So as a designer, being at this table ensures that you start telling people this is not acceptable, and the texture that I expect needs to go all the way around. It's the first real manifestation of what you did. Everything before this and everything up to this, you've been driving, you've been leading so that you can hold something that's close, very close, but now you have the final pieces that you need to get it to the next step. DVT is where we start to actually, can we make a lot of these? We need to also start meeting cosmetics. Appearance, requirements. So we'll do the first build. This is where we start to texture the tool. It is done by manufacturing operators. So now you've added in a new layer that you didn't have last time, and that's a very risky layer, because at the end of the day, they're going to look at a drawing, they're going to look at a standard operating procedure, and they're just going to be reading that without the passion, without that connection to the brand, to the design, and they're just slapping it together. So have you thought of how they're going to think about it so that you can control your product? We start dealing with times to make things. You see the word yield there. We're starting to influence yield rates. This is where we really start to worry about it. We also start doing large buys. This is where you start thinking about how much plastic do I need? How many chips do I need? Yeah. In the end, the activities, you've got your regulatory testing almost done. I keep saying that because it ends up becoming a really big problem. That product where I showed the 2 factory pieces, we had some major regulatory issues dealing with, as an industrial designer, who thinks about radiation leak of an HDMI connector? The radiation, there's a certain amount that the FCC lets you have, who to thunk? And you have to control that. And part of the solution is the enclosure. Part of it is thinking creatively of how are we going to shield that connector? Is that connector always open? It becomes an industrial design problem. And not having an industrial designer at the table means that an engineer gets to put on whatever they want. Or in worst case is a manufacturing engineer puts on what they did last time. And it doesn't fit the design. This particular item was designed by an amazing designer in San Francisco. I mean, his team is in the factory with us. Our team is working with us closely and in the factories because they know they have to own it. If not, the clients wasted their time and their money. These other plans are important down here. When you start to have inspection and quality control, at this point, we're starting to drive what matters down the road when we sustain it, when we manufacture it. This is where we're putting that in sand, or sorry, in stone, and we're writing it down. The golden sample. You'll hear this word a lot, but this is where you finally have texture, finish, everything. You know how to make it, and it's perfect, and everyone is signing off on it, and everyone is saying, we will accept nothing less than this. This is kind of, in what we're talking about tonight, what I'm talking about tonight, this is the point that you guys need to own. This is the part of going all the way through, embracing this, respecting this, so that your golden sample is what you sketched 10 months ago, right? Like that time gap is huge. All the people that have touched this, engineers that couldn't care less about your beautiful design, all they want to do is get it designed so they're cutting steel because the customer said, I got to reduce the bill of materials. I got to get to market 3 months earlier because CES was rocking this year. Stuff that you don't even think about 12 months ago. So I bring this up because people need to own this. We all as designers, this is how we make it real. All right, turning into a preach. So in this phase right here, you'll start to see, I put arrows right here. You start to see what looks like a shadow. It's not a shadow, that's a perfectly flat surface. It's just lit to show that. And what we've got there is behind it, it's an accessory bay door, and there's a perfect little wall that goes up, and the plastic is basically tinting itself as it's cooling from a thin wall here to a thicker wall here. You start to see the taper between the materials at different cool rates. So there's different solutions to that. You start to think about how do you manage the tool, how do you manage the flow. All things that tooling engineers will handle and take care for us. But if we don't point it out, something like that ends up shipping. And that is just you designed better than that. Over here, you start to see these scuffs and these scratches. These are not, something that happened in shipping. Those are flat out in the tool that is happening. The logo is in the tool itself. So the logo is being defaced in the tool itself. And people thought this was okay, right? This is a tooling engineer who doesn't have that passion, doesn't care. For them, they're popping parts out and they look great. We need to go in and point out to the people that are doing this, it's not acceptable. It needs to be perfect. And another big one was this glossy piece, and there's a video I'll show later. It shows the battery cap that goes over it. We needed those 2 pieces of plastic to be made in the same factory and molded at the same time. They didn't have to serialize. We didn't need left and right at the same time, but we needed lefts and rights happening from the same batches of plastic because we wanted that exact same black tint, and it'll never be the same bag to bag. But we needed it to match 100%. So if we could get them to inject them together, keep them together, then we assemble them together, we got it. So the last stage of this NPI manufacturing part is the PVT. And the real function here, we need it to be at scale. So at this point, we're hitting capacity and yield rates. We're basically scaling and building more factory floor lines of what we learned in the DVT. So like I mentioned, yield rate, cosmetics, you kind of see that repetition, right? It's not a lot of new stuff. It's a repeat, but every time they're getting more important. They're getting to a deeper fidelity level. Activities at this one, we now have everything we need to ramp to scale. In DVT, we bought everything. At this point, we actually have everything. We're ready to release to MP, and the documentation section there, that's literally about a month to be able to get all of those documents properly done. You can serialize it. You don't have to do it in parallel, or I'm sorry, you can parallelize it. You don't parallel. You can run it in parallel. You don't have to serialize that part. So as you're going through this, you're replicating the line. Part of that is an amazing amount of documentation that's based on that golden sample before it goes to the factory or to the customer. And this is where you start to see, and sorry that this isn't, that shading that was there is 100% gone. And that is not a painted part. It's not hidden behind pad printing or anything. It was literally the tooling engineers being told that that's not acceptable. And I'm choosing those words carefully because it is their responsibility, but it's our responsibility to point it out to them. It is our responsibility to ensure that they know what is good and what's not good. And you'll see over there, they nailed it. That is a fingerprint, this right here. That is a, they nailed it. They got it right. They fixed those blemishes, and by having the right tool, and we talk about having the right manufacturing partners where they respect their tooling, where they respect their machines like their EDMs, and they respect all that, to them, this is pride now too, and they recognize your effort, your passion has elevated their game, and they're shipping a beautiful product as well. So this one gets really long as well. You are cutting steel. Cutting steel takes some time, but then as you start to go on EVT, DVT, PVT, they get a little smaller. DVT is meaty. DVT is a very tough one because that is where you start to have multiple cycles, tooling or tuning a tool, and that can take a very long time. Early on, I started to talk a little bit about where you're investing your time, and I can't stress enough how important this is the big part to really dig into. All right, stitching it together, big shocker. You finished your design 22 months ago, and the first product is hitting the freight to get on an airplane or to get on a boat for 30 days, cross the ocean, sit in a third-party logistics partner for a couple of days, for someone to put it in a truck to drive it to an Amazon warehouse or to a Best Buy warehouse, and then it sits there for a month, and then it goes to a customer's hands. So when you start to stitch that all together, this 11 to 22 months, your baby has left you, and other people have owned it. And it is up to us, I can't stress this enough, to be part of that. The Nebbia shower, that was less than a year. I'm going to show another example coming up of a trimmer. We did it in exactly 12 months. The drone that I've been reflecting on that we've been showing, that was 16 months from a handshake to bringing in the design partner, Astro Studios, to do the design, through to shipping and the first units on the doorstep at Best Buy, 16 months. Ridiculously fast, but only because everyone was working together and no one was left off in a vacuum. So, going a little bit back to me and a little bit about what I'm passionate about, as I share all this part, what do I care about? Design engineering NPI is long, it's rigorous, it is hard, but at the end, this is how you actually build, in my opinion, businesses long term. This is how you build a brand versus just a product, because it is fully under one control. This is, when people use Apple as an adjective, this is a big part of how that magic happens. This is a big part of how they present their full ecosystem to you, to where every step of the way is curated and managed by them. All right, so this is the final product that we've been kind of showing along the way. We ended up doing the drone itself. Batteries was a big part of it. The storage bay had a couple accessories. Another product was the controller itself. It was a dead front controller, meaning like when you turn off a phone, it's completely black and dead front. When you light it up, it lights up. So we wanted that on this controller also. And then the gimbal. The only thing we didn't do was the GoPro. The gimbal was a totally separate project where we brought in a gimbal specialist that mounts cameras to the bottom of helicopters. We taught them how to think small because they were used to thinking big, and they taught us how to move a camera properly and stabilize it. So we put together a little video that'll let me take a break of that whole process. So these are the engineering builds. This is where we're going through that failure, where we're going through that testing, lots of printing, lots of builds. And then working with contract manufacturers in China, 2 or 3 of them. This all went together with a couple of them to actually build it. There goes the battery cover itself. It amazes me how many people it takes to put together what we all assume, just open a box. When you really see the line to hit volume production, how many people? So 3DR was a company that came to us they wanted to enter into the commercial drone space, and the commercial, I'm not supposed to call it drone, but the quadcopter space. Drones work for the military, the rest of us buy quadcopters. And what they really wanted to do was go from a hobbyist company based out of building products out of Tijuana to a commercial. And along the stepping stones, their plan was to go through a commercial product for consumers. They own the flight control software. We did everything else for them. We got them in and out of it very quickly. Time was the currency that they cared about the most. In the end, selling this drone was not their end game, right? Their end game was actually to prove their software at scale, to get it into the commercial world, because they were definitely seeing the consumer use of quadcopters is pretty limited. I mean, outside of realtors and wedding photographers, it gets pretty small pretty quickly after that initial bump went away of what to do with a quadcopter. So they wanted to get into that commercial. We helped them get through that. We also helped them with the business plan as they were going through owning inventory. And this is a little separate, a little different, and we can talk about it later, but we offer the ability to help customers with their inventory control and their inventory management and payment timing so that they can go out and sell, raise money, create that and go back and forth, but we can produce at scale at one time and just fill a warehouse. And then we also help them at the end, once they met their business needs, how to actually liquidate them and get them out pretty darn quickly. All right. So at this point, I'm going to take a shift from the design engineering and move over into the manufacturing models. Any questions on any of this so far? Yes, thank you. Fantastic question. Thank you for asking that. Absolutely have had plenty of people say no, like yes. I'm sharing this, and I wanted to share this to kind of change that, right? To start here and make us all, it's taken me, I graduated, what was it, 96? And 3 years ago, I started really becoming aware of this part of the journey, right? So it took me a long time to be aware of this. Only by moving out of industrial design and being a lead in an engineering firm tied to supply chain management. That's what we do, engineering to supply chain. The three of us that are part of the leadership team that run that, the other two spent time at IDEO. They spent time at Herman Miller. So they're all design backgrounds. All three of us hold design degrees. All of us have that passion. We want to make things real. So this is a big shift that we brought to the world. This is what we all focused on and what we wanted to do. I got to join 3.5 years ago to elevate that, to build that. So I don't know, I've definitely seen people not respect it and not want it. What I want to really do is share my learnings of the last 3.5 years back to industrial designers, back to design community, that you're seeing this with the years of experience, right? And that you're able to be part of that change. I'm not going to be able to hand you the change today, any of it, I wish. But you guys can, that's in this room, and it starts with you guys. As you get into jobs, as you get into delivering hardware, there'll be the first part of it where, you know, people will embrace it and the right companies will get you to China. We get our engineers out all the time. We have design partners that send their people over. Again, value, who cares about it? If they care about the design, they will send you. Plenty of times that I had a Chinese visa in my passport, a 10-year visa, and I was at Frog. Plenty of times, even after I had left creative direction, where you're a designer, get to China and make sure this is going right. You have a visa, you can go today. So it can be done. Tons of people don't want to do it. It costs money. If they have the values aligned to the quality of building a brand, they're going to care about this. You're talking about this timeline here?
Yeah.
Let's go to the slide that has it all. Trick question. The red, absolutely, you don't need to worry about that. These upfront ones, there's a definite tapering out. So my answer to your question is really going to be upfront, you need to be involved a lot. And is that maybe 80%? Versus back here, you're only involved 50%? This ends up taking, months, right? This is up to 8, 9 months, up to 11 months. So you don't need to be at every tool build. You don't need to be 100% involved into everything like that. But in each of those phases, you need to be applying time and you need to be applying a lens. So yes, you need to be involved in there. So in develop, as the engineers are making decisions, we have the design firms and the designer sign off on the work that we actually, so we flip the table, right? So we're answering your question preemptively by ensuring that the designers are there. We don't want to encroach on the design. And we have agreements with all these firms that we will not change your design. So they sign it and they bless on. We force them to come in a lot during develop and early on to bless all of our work. And it's humbling, like really truly, when you have an engineer whose passion it is to do amazing work, to interpret a design, right? That is their job, and to make it real. And to have them take the back seat and say, is this what you wanted? Like, that is a very humble moment in an engineer's career. It's tough. And as designers, we also need to go in there and be very forthcoming and honest, but also be very respectful that this was their passionate baby, or their passion baby 5 months ago. So how do you do that? So it's tricky. But that might even line up to how do you get involved more, is showing that compassion and showing that empathy and respecting their passion up front. The design part up here, it's important, but at that point, they're really listening to the designers anyway, so the designers are involved. Cool. Any other questions? So engineering builds are going to be the noun, right? So we're going to be doing these engineering builds, EBs, and they are work stream based builds. They are about risk elimination. And then the fail quickly is just get through them as fast as you can and fail a lot. So the prototyping, right? So we run the CNCs, we have the staff that's running those, we have the 3D printers, the engineers are screwing things together themselves, they're coming up with creative ways to do the test plans. We have life cycle testers that our engineers have built themselves. Tons and tons of the action verb part of that of fail a lot, fail fast. A lot of people say it that way too. Yeah. Yeah, that is a tricky point, because does the industrial designer think about that? Or does the design engineer? The manufacturing engineer, definitely, it's crystal clear, they do not. But as you're going through the requirements, I'm a big believer in the requirements guide that. And if the requirements say, we need to make this durable for a 5-year-old to throw it against the wall, you know, I haven't had a lot of experience that way, but the drone had to fall from a 30-foot drop, I believe, onto concrete and could only break legs. Everything else had to work. So it's not a kid, but it's a very similar relationship, right? Like, we had to prove stuff, and we had to test often. We failed a lot by actually doing empirical data and dropping it. We had a post on the roof, and we dropped it off that building you saw. And the specifications drove exactly what we had to do. It was all defined in that architecture of, okay, we're going to start to create the legs that are removable, because we might not be able to solve this all the time, but if it does, customer, are you okay with that leg being removable? And that leg, not a lot of the competitors, the DJI one, is not a removable leg, right? So that removable leg tangency became a patented piece for them, right? So they actually created something else that you are not going to see without them knowing about it. I believe the specifications start to drive where that falls. I don't think anybody gets to forget about it. It has to be all the way across the board. So we don't. We're not we're not a brand, right? So we support brands like that. We're going to talk about the manufacturing cycles, the manufacturing types, and they are vertically integrated. So they're close to a good example of what we call an original brand manufacturer, an OBM. Large part of our world talks about OEMs and ODMs, but they are actually one level above that, and they are vertically integrated. Samsung's another example of that, right? So they're so deep. How you compete with them is going to be part of that brand promise. And yes, it takes you longer to get to market, no question about it. But there is a reason to buy a Samsung versus a competitor, and vice versa. And there's a reason people buy a lot of DJIs. But DJI is also, and we don't work with them. I don't know anything outside of what I read and what I see. They're also moving their business and evolving outside of that world of doing quadcopters. And how do they stabilize images? How do they move to camera, right? So they're not just vertically integrated, but they're also changing their business model consistently. I'm just gonna say, that's just super smart business, right? And everybody should be competing with that. And to extrapolate on that, we start to do testing for FCC. You'll hear me talk a lot about like that part of it too, because it's just been a real pain point lately. But when you start to do 3D printing and you're testing a capsule of some sort and you have your antenna inside it, is that the real piece? How does texture change it? How does coatings on the inside of the plastic change? So that all goes into the work stream and what you're solving at that time. So those plastic parts that we were dropping, even in the engineering, in those engineering builds, in the develop phase, we were cutting aluminum, we were cutting soft steel. There's a guy named Elfie, and Elfie cuts parts for us, and he cuts steel. He's done a lot of stuff throughout Silicon Valley, and he's got a small injection molding shop. We move as quickly as we can for those tests into injection molded PCABS, right? Into the right material. It's not perfect until you cut steel, and it's textured, and you're doing the back here part, the NPI phases. So in those early phases, our work streams dictate what can be tested, knowing that there are limitations like that. An SLA is going to shatter. A 3D print that is sintered is going to just fall apart. So we have to take that into account. But there's other tests we can do with that. So how does that motor actually mount? Are we going to be able to DFA, assemble it? Are we going to be able to get the screwdrivers in the right spots before we close it? Are the LEDs going to properly light a a frosted lens and give us the texture we want? Are we able to get the LEDs to breathe the way that we want them to do? Knowing it's not the perfect frosting until it's done. Does that make sense? Yeah. We just have to shape our expectations and our test plans to what we're testing at that point in time, knowing that that gets closer and closer to what you're asking of this is final product, this is final test. No. No. I've heard where it started from, I've heard multiple stories. I don't know exactly. We're adapting process that are used throughout Apple, IBM. I think 3M has a version of this. So no, absolutely not. There's nothing proprietary. There is nothing that you can Google this tonight and you'll find tons of different versions of it. They might have different names for things. You'll start to see things like EVT1, EVT2, EVT3. That's abuse. You should never have that. But great question. Thank you. And the reason I say it's a great question, we're working on like how do we build our business, right? So I have the other lens of running the business part of it. And how do we find new clients? And we've clearly discovered in looking through proposals that I've written, clients we've met, projects we've won, and you start to look through it, we found a couple of threads. And we're extremely successful with engineering-based companies, clients. So if they understand the engineering process, they look at this and they just say, of course this is how you do it. I don't know why anyone else isn't. Please start on the project. Then we have clients, L'Oreal is a fantastic client of ours. They have no tech savvy on hardware. They have tech savvy in chemistry. They have amazing people in packaging. But when it comes to what we've kind of coined with them, this world of beauty tech, they have no understanding of how that works. They go through this process and they go in eyes wide open and they give us a chance, and it comes out the other end, they look at us and they're like, wow, this is amazing. So we're really successful with technical and non-technical. Down the middle, people subscribe to very different versions of this. And when I started out the conversation, I was really starting to share, like, this is my view, this is what we do. This is one of those parts of down that middle swath, we don't win a lot of work. No, because people will have their own way of doing it, and we might not dovetail into their systems. We might not fit into the way that that product manager did it at a prior job. We're working hard to adapt this to kind of embrace that differently, and how do we create things that I like to call on-ramps and off-ramps? Where do we, right now we need the process to go all the way through. We've got a couple of off-ramps along the way, but if we can create different ways to embrace a customer at a different level. So maybe they bring us an architecture and we only have to take one step back to validate it and now bring it into our system. How do we do that? We're trying to look at different ways to create on-ramps and off-ramps that allow for other people to have their process and dovetail into ours. Hire really good BD people. Finding our customers goes through our portfolio, bluntly put. So we have not done a fantastic job on marketing ourselves because we've been so busy that going out and telling people for more work has been kind of like, we can't do more work right now. But building a portfolio, when I started 3.5 years ago, that was a key focus for all of us, to get a portfolio in place to show people how to do this and how we do it. And that makes its way out there. It's a small community. Everybody's talking. Our phones ring off, not off the hook, but our phones ring. Our email rings, or dings, or toasters, or whatever it's called, shows up on a regular basis of people that want to start work. We tend to scope out projects early on and weed out the people that are not a fit, goes to kind of that question. And of the proposals we write, we're pretty darn accurate of about 50% hit rate because we've done such a good job weeding it out ahead of time. So right now, finding those clients, they're finding us. And we're in a really fortunate place. Part of this answer before was kind of where do we expand that? It can't exist forever. We're looking into that too. Yeah. All right. I'm going to take a deep breath. We're going to move on to manufacturing models. Are you still yawning?
Yes.
Okay. So again, on the manufacturing models, I'm going to be talking about the three basics. There are tweaks, there are different versions of each of these. So these are the main big ones. Little versions of each of those you might have come across, you might come across. We're just going to stick to these today and know that there's variations out there. We would be here all week if there were more. But it comes down to your product, and those values will help you drive what factory, what type of contract manufacturer to go to. Another piece that I didn't put on the slide, though, is what do you own? So we as a company do the supply chain piece. We don't care who we work with. We work with contract manufacturers of all sorts. Our job is to stitch them together the way that our customer needs. So we're uniquely positioned to solve all three of these and provide for customers for all three. There's a couple of us out there that do this. Most of them, you end up being a brand and you own everything, a design manufacturer and you own certain technology, or you are equipment manufacturer and you are owning capacity and capability to fulfill a spec. We'll talk about each of that directly. But knowing what the paths are, just like knowing the paths for the engineering, and knowing what your limitations are, knowing what their expectations are, let you start to drive it. And as you drive it, you're driving closer to the customer. You're driving closer to what they care about. Okay? All right, there they are. So the three major ones, the OBM, we talked about DJI and Samsung. When we talk about a fully integrated value chain, and they're so deeply integrated across everything, they're making components, they're making chips. They are working on the plastic. You know, Henry Ford is the perfect example of this. When he started building cars, he was taking in steel and building the canals to get them to Flint, Michigan, to be able to build or make the steel, to start shaping the steel, to start bringing it together. And he needed something to bring it together faster, so he invented the factory, you know, the assembly line. So this original brand manufacturer really goes back to that of you own everything and you build your own factory. It's not a lot of people out there that do this anymore. The design manufacturer is a little different. They tend to own a technology, and a perfect example of this is Bluetooth speakers. Everybody's shipping a Bluetooth speaker, and they all look cool. They're beautifully designed. They're all great. But inside, there's only a couple of technologies doing the communication and doing the speaker itself. Processor is a commodity. So these ODMs, you walk into these, and when you get a chance to go to China to these factories, you walk in, and there'll be a display room, sometimes the size of this classroom, and there'll be all the product that they've done, and you'll walk through just giggling because you've seen this, you've seen that, and you're coming to them with a competitive product, but you're going there because they know how to do that technology. And all you're giving them is your specifications. Maybe you want to put in a different type of amp. You want to put in a different type of music processor so that you can get closer to a raw data, a raw type of music. Maybe you're bringing them a CMF they've never done before because you know they've never done Chrome. None of their other people have, and you want this thing to be beautiful in Chrome. I'm not saying Chrome's beautiful. And then you have the equipment manufacturer. These people, you just give them a spec to your product, and you walk away. I'll send it to you. And you walk away. Now, the spec itself needs to be very defined because these people, they own factories, they own floors. The contract manufacturer at the bottom, and I've separated it out because many times these three are leaning on one of these. So a CM, in that video you saw, there was a OEM, it's called Jabil. Jabil was manufacturing that. They are top tier, they are the best of the best when it comes to making hardware. They are technically an OEM. You give them a spec and they build it for you. But then there was another person holding that plastic piece and it said TK Plastics. They are an CM. So we were stitching together an organization to create a virtual brand manufacturer for the client 3DR by leaning on an OEM for major parts, final FATP, and we were bringing in our own CMs that had capacity and capability and quality that were going up to them for final assembly. It's cool. It's really cool. All right. So what I'd like to do is kind of put this into a different lens. So those are the capacities, the capabilities, why you go there. take a step back with me for a second, and this is the Stan Shai smile curve. Stan Shai was the CEO of Acer 92. He came up with this. And what he was really saying, Acer at the time was going into the commodity trap. They were basically just shipping cheap computers, and they weren't making any money on it. They weren't going anywhere with it. And what he really did was he started to look at, to get from time to manufacturing and the value proposition, if you own the top, and you start to, the next slide should actually start to put some labels on it. When you start to own the technology, when you start to own the patents, when you start to own the design, you can craft and create a lot of value that people want to pay. And at the other end, at brand and post-delivery services, there's a lot of value to be gained. In this bottom section of the smile curve, you're just making it, you're counting fractions of pennies, and you are trying to go for volume, volume, volume. So that, we've all heard that before, but this is how it maps out to what we do when we actually have to make something. So another lens of that is when we start to break up the three: low value add, high value add, middle of the bucket, we start to add in our world, creativity. So up here, you're starting to, this is where you're adding the industrial design. Ultra high value, right? So to the brand and to the customer, you can charge a lot for that. Over here, after services, that is actually very expensive, and treating a customer properly gets expensive. We all know what it looks like when it's not good. This R&D portion, people don't want to pay for it. They expect you to have done it before. I deal with customers a lot on legal conversations where they want us to own all of that. We actually play in kind of like the top. They want us to own everything in the middle, 100%, own all the patents, all the IPs. They want us to know that we have zero infringement on any patent anywhere on the planet. It is impossible to do that. No law firm will give us signature and take responsibility of it either. So there's no real value to be had there. And again, we talked about the manufacturing. It's counting pennies. We're going to add another lens to this. Where do they fall, right? I mean, that was pretty obvious as you saw that coming. But now I'm going to switch it on us and put our world into it. We talked about the design engineering. We talked about MPI. They live in this bottom part of the curve. So if you're only living in this world, you're kind of driven to this, right? You're going to be stuck dealing with ODMs and OEMs. But when you start to add in the layer of what we bring, the creative part, you start to really see the value that we can add has gone up the smile curve. Does that make sense? So we talked about this already. Like, this is the part that we are talking about tonight. The ID portion, that specification part, you guys have got that. You bring that to the table. That's what you're here for now. This is the part that I'm sharing today. This is the part of how it fits into the value and connecting what we talked about on design engineering and MPI to the value proposition, to the brand itself, to the customer themselves, and where they are going to live. The manufacturing types over there, they become your asset and your tool to lean on and manipulate. Okay? All right. So, the short of it, we need to respect them. If we can respect them, we can change them. We can optimize them, and we can elevate them. Nothing drives us more crazy when a tooling engineer, sorry to put this into the bell curve right here, a tooling engineer is telling us that you can't do that. Because the reality is, we need to push that. We need to push them to do what we want because we want to play at that. We are offering a value, a service at that top level of the smile curve. That value proposition needs to be pushed all the way through the curve. And then the opposite is equally true. I have to say these words. Ignoring it will kill your design. If you don't know this, own this, drive this, be aware of it, respect it. Your design will be killed. We talked about the timeline. That's why. So my approach to all of this has been to focus on those high points because of the high value proposition. As designers, it also lets you work on the really cool stuff because that's where the people are willing to spend the money on the design. They're willing to spend the money on beautiful materials, on finishes, all the stuff that we all love and why we're in this profession. That's where they let us play with it. And lastly, Owning a carefully crafted plan. When you asked earlier about getting involved, this is part of it. Crafting the plan, knowing it so that you're respecting it from the beginning, and sharing that so the engineers know you know what you're talking about, that they need you at that table. That's how you're going to start to drive this change. All right, another example of driving that change. This is the trimmer I might have mentioned earlier, design firm out of New York called Black & Bone. There are no visible fasteners. You have a forged and machined back half, and then the cord snaps off, or cord pulls off, it twists off. There's a rechargeable AA, or you can put a standard AA battery in there. The cord itself unplugs. There's a little hanger for the prosumer and the barber shop itself. The overmolded piece, 0-part line. It's a perfect fit. I mean, this is in the factories, her name's Suga, in the factories, on the floor, making sure that every part fit perfectly. Yield was terrible on this thing. As our engineers went through it, the product engineers working on the product, we drove that yield up. We had problems with the battery life. We had problems with the torque of the motor, driving the blades and doing the task of actually cutting hair. Working with the firmware engineers on the ground. It was a learning for me to see how the firmware engineers were driving up such a physical solution of battery life and torque on the motor, all solved in software. The blade pops off with a single motion. None of the competitors do that. You can rotate a little wheel and it adjusts the gap itself to a 0 gap so that you're also shaving all the way down to the scalp and not cutting the head. Only a couple people on the planet make blades. Going through the EDM process in-house of being able to design the blade shape and the taper of each of those, our engineers owned all of that through the engineering phase. This was 12 months from handshake to Amazon. Only off-the-shelf parts are the screws and a couple of other random pieces here and there. So cool. All right, I'm going to do a quick piece, be mindful of the time here. I'm going to do a quick piece on the cost. And the reason I'm sharing this is a back pressure. So everything I've talked about here is kind of, you guys got to lead this. You got to lean into this part, right? You have a voice, respect it, push, push, push. This is the part that pushes back at you. And it's valid. It is very valid. So we're going to take a quick look at it. But again, if you know it, you can start to respect it and lean on it. Some acronyms: bill of materials, a bag of parts. And the COGS is the cost of goods sold. The cost of goods sold is, in my case, our price to the brand. So that brand, when you start to talk about a 1-to-5 ratio for most consumer goods, that's based off of the bill of materials. I'll show you the spreadsheet in a second. That's the bill of materials that is usually 1-to-5. You can have anywhere from a 30–50% margin on that to get that into actually a product, assembled, quality controlled, plastic on it to protect it, ready to go into a package itself. Yeah. So it's showing up a lot better than I expected. That's very good. So on the right side, we have a tool that we created called the Enigma, and it kind of decodes the whole process for finance. Behind this is another spreadsheet that is definitely one of our proprietary tools to go through all of the costing for the top part, everything above here. So you'll see that that's zeroed out, but I put in labor and expenses and kind of to break out what it is. But that is definitely proprietary to our company of the costing that gets through that. I'm going to show a math sample later where I basically just say to get to this number is $3 million. That's kind of dead center. I'm going to use a $43, $26 sample. So what I did was I put in some numbers here that have to do with the bill of material, and I put in some information here for the annual volumes. Everything else works through with a couple of other levers and a couple calculations. But it really lets us break down to a customer at the bottom how much cash they need at what point in time. And the next slide, we're going to talk about when they move a lever, what does it mean to them? We need to think like that. So top part is time and materials. You can just imagine that's hiring the engineers, hiring the designers. We scope that out. We quote that out based on those work streams, people that are going to work on it. Excuse me. And then the volumes, I've pulled out making 10,000 a month and then just doubling it every year for 3 years. Then you get into the bill of materials. And this early in a project, I see what you're saying. No, I didn't take that out. It's from something, yes. So I put in some actual numbers here for the mechanical engineering BOM, the EE BOM, and you come up with the total for accessories, assumptions, cushions, and everything, basically saying the parts bag is $26. To convert that into a factory, take their support to make that. That includes their profit, that includes our margin. We make money along the way too. Kitting and fulfillment is starting to put it into a box, starting to think through what is that going to cost. In this case, you're adding basically another, looks like about 80%, I didn't run that, but you're taking $26 to $43. So that is what we would sell this hypothetical product to the brand. Now the brand is going to see the 26 and they're going to see this is 17, and they're basically going to buy it from us for that 43. Now they need to go and sell that to a distributor. The distributor they want to make money, so they're going to make 25% margin. They're doing pretty good. They're going to make $14. Then the distribution center, who's going to own selling it and getting it into the Best Buys of the world, getting it out there, they're going to want their 25% too. And that's still, again, it's a modest number. And then Best Buy wants their money. And Best Buy ideally, or the retailers in general, let's not pick on Best Buy, retailers in general will want a 50% margin or 100% markup, right? So if they're going to buy something for 20, they're selling it for 40. You have to drive that down a little bit because they will also have allowances for things that don't sell. They'll have some other allowance. So they're not always getting that. So we put in something like 40, and that will give you literally a BOM to retail of 1 to 5. Cool, right? Simple. It's not hard. Now, they're going to spend with us the $43 with somebody to make it, whoever, it doesn't matter. They're going to have to buy the product. You're the customer, or you're the brand. You're going to buy your product. You want a whole container full of them. In year one, you're going to sell 120,000. You're going to buy them for $43. You need to have $5 million cash ready to have that container get on the boat, because it's not leaving China until you transfer the money, unless you're Samsung and you own the boat. So it's not all at once. Down here you start to see minimum orders, or MOQs as we call them, minimum order requirements. We start to put into that piece. So you don't have to have the 5 instantly. But if you have no credit, if you have no history, if you're a startup, people are going to want to see that in a bank account somewhere before they let you place an order, before they go through all of this craziness to know that you're actually going to order 120,000 units this year, or 60, right? Like it might need to not be the whole thing. But my point here is really, that's a lot of money when the last 20 months, all you've been focusing on is 26. As a BOM, all you've cared about as an engineer, as a designer, is the BOM price, the BOM price, the BOM price. And then people have talked about how many units. When you extrapolate how much that actually is, it's a lot of money. So, woo! Yeah, no, I want to get out of the sun. Early on in a project, in the other tabs or the other worksheets in this Excel spreadsheet, you can start to really pull levers and get factual. So early on in the very beginning of a project, when we're even before architecture, as a company, we target having this nailed with a very high level of certainty before we leave architecture. It's a competitive advantage we have because we're connected to factories through our supply chain network. So we want to bring that data forward, and we do that as a competitive advantage. We don't know of anyone else that can do it and bring it as far up as we can. And so this gets adapted through every phase as these numbers get adjusted. So this number right here is going to get adjusted very quickly. Customers will start to see, how many am I selling? How many orders am I getting? Later on in the project, there's this thing called sell-through, and how many actually leave the retail outlet, not the distributor. Some companies will look at what goes in and out of distribution centers, and they'll see, ooh, I'm doing great because all this product is going in one door and out the other door, but it's leaving distribution. Where's our distribution number, right? It's leaving distribution, and then it goes into a store and it sits on the shelf and no one ever buys it. So then people start seeing, oh, this warehouse is empty, I'm going to refill it. But now their stores are full and their warehouse is full, and all of a sudden, even if they could sell everything, the time frame to get through that revenue, to sell all those boxes, to get all that part, is forever. and it kills a business to not look at sell-through at the retail level. And there, believe it or not, are tools out there that aggregate everything that's going through every major retailer, and you pay a service fee, and you have access to your product shipping through doors on a day-to-day basis. It's mind-boggling when I learned that one. Any other questions? So now I'm going to scare you with this other one. And this is not meant to be scary. It's definitely meant to kind of put the numbers out there to show what happens if you reduce a bill of materials by $3. Or is that the next slide? Sorry. No, that's this one. So after the design is done, we're going to spend $3 million. The brand is going to need another $5.2 million. So in year one, your client has spent $8.2 million to have 120,000 of something and generate $6.9 million. That sounds like a lot. But at the end of the day, it's $1.7 million of margin that you have to go pay all your bills from. And when you start to think about that over a year, $1.7 million running a business is not a whole lot. You've got a lot of bills to pay to get rid of things, to sell them. So of all of that, at the end of year 3, you start to see that they've only got $10.4 million total. That comes to, I did the math, where was it? $2.5 million after you pay back your $3 million to yourself. $2.5 million to run your business. That's sales, marketing. You want to get paid. The client wants to pay the salaries, right? You want to have a holiday party. All those things come out at $2.5 million. And when I've lost my notes. So what I did was I reduced the COGS to create that back pressure that I talked about earlier. And if you remove this to $40 and you take the brand margin, they want to actually sell it for more money to $17. So you're moving $3 in 2 places. You end up pushing this up $500,000. So you now have another 500,000, sorry, per year, up here. Per year, you move the needle $500,000. That's $3 of texture, of the type of plastic being used, of is it a glossy finish, is it a dead front, is that something that's concealed, is it IP rated in a waterproof seal or not. That's $3 on the bill of materials on the COGS, and then them trying to sell it for $3 more. It's kind of a big lever and big back pressure, and when we remind engineers of this, and they start to see like, oh, the client's just beating me up on this bill of materials. I need another $20 because that Maxon motor is $28. They only have $8 in the BOM. Can't do it. You just went the wrong way, and eventually they're going to ask you for another $3, $10, whatever, to reduce that. So the real purpose here is not to put a bunch of words and ugly slide up there of Excel stuff, but to really make you aware tiny little numbers at scale make a huge difference. And when you think this through with pen and paper, and you think through the volumes, you'll really quickly see why the customer is pushing on some of these things. Any questions on that, outside of the format not being clean? Cool. So now we're going to talk about some pretty pictures and wrap this up. So this is a client we've been working with for about 2 years now, being produced in Fremont, California. And this is one that we are taking care of here in Fremont. Kodak out of Rochester, New York, came to Yves Bahar at Fuse Project and came up with some beautiful renderings that look exactly like this. This is actually an EVT1, EVT 1.5 that was made for CES. It runs most of the software. It's not completely perfect to be called an EVT2, where we were solving some more problems. But we built this thing. We did about 2 years of engineering. Yves did about a year of design, has been with us through everything. We released it at CES 2 years ago. Again, this year there were some more. They're getting ready to start shipping this thing. And it is a true, honest 8mm camera at scale. And nobody was making inside the engine that actually aligns the film, the light, and locks it and stops it at the right speed. So Kodak introduced us to a company out of, I believe, Norway, that 2 guys in a garage were making a couple hundred of these things a year. And the idea was, we'll take their design, tweak it a little bit for manufacturing processes, and go. Our engineers spent 15 days on the ground with them and really came back and said, we got to redesign it. So we ended up spending 9 months re-engineering an 8mm engine that Kodak had somehow, they'd done this for many years. They'd lost all of that. We had to re-engineer it. It is beautiful. You can't see it, but the leather wrap that goes through here, the pistol grip, the leather up there with the camera, it is stunningly beautiful. And bringing back the 8mm is really cool. Each of these I've thrown in a little bit of the exploded view to kind of see it is an engineering approach on our side. Here you see all the different parts, and the engine itself is actually it's inside there. Yeah, sorry. L'Oreal, as I mentioned, is a very large client of ours. Been working with them for just under 3 years. We about 5 or 6 different projects every year with them. This is the one I was talking about in the class earlier today. This was designed by also another student here from Long Beach who ended up graduating at San Jose State, but another Long Beach person designed this thing, Josh. And this part pivots, scans your skin, a bunch of different LEDs and light sensors, about 14, 15 of them. On the other side of that is an Android device, and it's basically an Android phone being used to process and then send the data of the scan that you just had up to L'Oreal's cloud, and then L'Oreal is able to take your geo-positioning, is able to take all of the scan data, mix that together, and make recommendations for the right type of lotion and cream that could be in the inventory in that store in front of you, or maybe not. With this ecosystem, we also created a robot that's in a couple of Nordstroms right now, where that can then be sent and it can be custom batch made for you right there. And you just put a little glass jar on it, it rotates around, it has NFC tags to know volume of all the different compounds, mixes them, cleans them, you take it off, put it in a little rotator to shake it up, hand it to the customer. In China and Japan, that's illegal, so we created a robot that's 15 foot wide, 15 feet deep, and 5 feet tall, and it holds large vats of it. You put a glass jar in, or it grabs its glass jar, it's ink jetted already, or it's ink printed already. We take a laser etch, we put your name on it, we put an NFC or a QR code on it, custom fill it, custom mix it, put it in a box, and we ship it off to L'Oreal, and then they fulfill it to you, one of one, custom, at scale. We've got another design of another version of this that I can't get into, but just imagine taking this thing home and not having some clinician do this, but you can do it in the privacy of your bathroom by yourself. This is a client called Latch. They are funded by Meyerhofer, and Meyerhofer made a ton of money on Apple. And with that, he is bringing the Apple design aesthetic. He's got an amazing eye for design, and he is bringing that to this lock. This is a smart lock for high-density housing. We're only doing the black part. So the lock itself is being done by a lock company. We have nothing to do with that. We are just doing the dead front display, IP-rated, this part right here. Other side of that is the black part there. You walk up to it, there's an HD camera that's in the right orientation to take a picture of you. It automatically illuminates the LEDs behind it, gives you a capacitive touch display. So you can enter in the code on the 10 key that gets presented. So you have a one-time access code that you can give your dog walker, you can give the Amazon delivery, give to On Track, one time. You can give it also to it's meant for someone having a doorman that you trust going into your house, right? And it's not something we're used to in California, but think in New York where you have high density and the doorman has a one-time code to bring that up that time. Or your dog walker has a code to come every Tuesday at 3 o'clock. All can be programmed. All right, couple more slides. We're gonna go back to what I started with. Hardware is complicated, it's a ton of work. I hope I've stressed enough the time frame between what we do in design through to it hitting the customer, and all of the different people and steps and processes and weather conditions that are going to happen between then, and how we can focus on being aware of them, respect them, and drive them. We need to solve our problems, but where we do that needs to be driven to what we're trying to do. We can't let go of the ID just because the design is done. How far the people let us go to the question of are we gonna have that access? We need to change that. We need to drive that. It happens. We do it. I'm doing it. Our firm is doing it. We're bringing it in. We're bringing those designers to us. But that's an approach that can happen the other way too. Designers pushing themselves that way. Working in-house. this is something that happens very naturally for companies that are in-house because that is their brand. They're carrying the same flag. But when you're working for a consultant, there is this like, hey, I need you to do this. I need you to do this. I need you to do this. It's a value proposition to solve this holistically. It is something that customers want. We need to present this to them and teach them that they need this from us. We need to know the paths, and then we can realize them. DFM and DFA are our friends. Design for manufacturing, design for assembly. Understanding that, not knowing it, bringing those people forward. How are you going to make it? How are you going to assemble this thing? Those are our friends. That is how we reduce time. It is a secret weapon. And then lastly, embrace failure. This question right here that you had about, failing often, you got to embrace it. It's not fun. It's humbling, as I mentioned earlier. But if you can fail early, fast at the beginning, it's cheap. And I don't mean money-wise. I mean time. I mean everything but the money part. It is cheap money-wise. It's easier to fail at the beginning a lot before you've gotten to the back end. All right. Any other questions? Get me out of the sunlight. Any other questions? All right. Thank you. Any other questions? For sure. And we'll use the words, they're a cultural fit, right? And that's what we end up calling it. But it is the personality, like how do we get along? It is most definitely important, but it's, in your question, you're coming from the direction of the hiring side. I think you need to come from the other side of you're picking where you work. You're picking where you fit in, and you need to be interviewing them. And it also shows confidence. It also shows other pieces of it. But if it's just them picking you, you've missed, is it you picking them? You're missing, like, is this a fit in what you really want? So I'm looking for people that are interviewing me. And that's a really, like, what I'm doing, we've already figured out that by the time I'm getting to an interview that we really love this person and we really want to bring them in. So part of my job is to also vet, are they a cultural fit? But I'm also trying to make sure that they know who we are, right? I don't want to call it that I'm like a sales role, but I'm definitely presenting who we are with crystal clarity, and I expect them to be interviewing me. And that is them vetting, do I want to accept this offer? You know what I mean? It's a little different twist to your question. If it's just them interviewing, ask a lot of questions. Like be not scared, but be inquisitive. Be very questioning why. Yeah, they need you. You don't need them. It feels weird in the boat you're in right now. I totally get it. You want to get out of school. You want to pay off student loans. Like I get it. Like there's a lot of drive of you also want to professionally get into the world and like contribute. Like there's a lot to all of that stuff. But don't ever lose sight that they need you. You don't need them. Yeah, they need you. It's a big part of the lens of even as we're in executive meetings and everything, we're truly remembering and saying the words to one another of, they exist just fine without us. They'll figure that out all on their own. We need to bring something. We need to contribute something. We need them more than they need us. Yeah. Teague is so long ago, I'm not comfortable. I was a designer. I had a blast. I had a great mentor in Larry. Great. I loved it. Frog is a very competitive environment, and it's very much based on that. And again, I left 3.5 years ago, so these things all change over time as well. I was part of a group. I got to work with Hartmut, excuse me, the founder himself for his last couple of years of being actively involved as my lead and my mentor. So that was an amazing part of it. As the company grew and grew, industrial design became a smaller portion, and I was adapting by learning and adding on all the digital side, building the experience side. I moved more into the business side. So for me, Frog was a fantastic experience. I can't tell you how much I loved it. In the end, it started to shift a little bit in its business purpose, and that started to create a little bit of a, what do they value, what do I value? And really, you know what? At that same time, Lime Lab came knocking and met two guys that were looking for someone that really aligned with what they were doing, and it was a natural fit. So that's the only reason I actually left, was I found someone that was really, I found another place that was really aligned to making stuff and building things, where Frog had gotten a little bit more to talking about it and really theorizing on it and thinking more 10 years out, really taking customers to a long journey. And I get more of a excitement on that 22 months. Yeah, it's a trick question too. Too much padding will scare them away. So in the part of vetting out the hours and the work streams, we spend a lot of time listening to them. We spend a lot of time of understanding where they are and where they're going with a lot of different people in the room. Excuse me. We spend a lot of time vetting out what they're trying to do. And it gives us a lot of accuracy by putting a lot of the right people, spending the right amount of time, gives you a lot of accuracy on that scoping and that quoting. We don't pad hours. We don't pad bill rate. We have a set bill rate for different bands. We go through and we present, here's what we're doing and here's how much time we think it's going to be. Because we're engineering and because we're being held to a technical engineered spec defining completion, we do time and materials only. We've had a couple of projects that I felt comfortable doing fixed fee, and we've succeeded and we failed from a business standpoint, right? I mean, it's you win some, you win some, you lose some on that, and you have to look at it over a certain period of time as an aggregate. When you do fixed fee, or when you do time and materials, we have clear where we're going, how we're getting there, what we think it's going to cost. If it goes longer, we expect our PMs to educate the customer along the way, and we expect them to drive change orders where appropriate. Where we messed up and we said that we could do something and we estimated it was going to be this and we're off, we eat that sometimes too. It's not black and white. But we don't pad. When you get into the manufacturing side, we share our margins very clearly and very openly. We expect the customers to be very open, but nothing is cast in stone until we get into manufacturing and our numbers are nailed down. Of course. I mean, design has a factor that's qualitative, and quality matters. And every one of us will do let's just call it okay, a non-stellar job, right? And it's going to happen. We all have personal lives. When we meet new people, when we're interviewing people, we're also vetting out how they personalize their problems and the rest of their life and how they bring that. We want to know about that because we want to, in our culture, we respect that. We have built a culture around transparency, work-life balance, et cetera. So in those pieces, we want to know about these people a little bit more than most people do. Those to us are some of the factors that create some of those days, right? The shit happens. And we as a company focus hard on supporting people through that. I personally, of course I've been there, right? I mean, it happens, and being honest with yourself, and it starts here, and being honest with yourself of, did you really do your best that day? Did you really do your best in that design, in that concept? And taking responsibility and not getting defensive, that came up earlier today too, is really hard. But that's the answer. That is the only answer. That no one in this room is perfect, and we are all going to mess up. Owning that is what any good manager and any good leader of a company is going to want to respect and foster. And if not, go interview someone else. Anything else? Bring a lens of, that's what you want, that is beautiful. I want it to be beautiful, right? I'm passionate about people that care about design. It doesn't have to be something I always think is beautiful, but it has value and somebody cares about it, and that passion is there. I don't question that. I make it my job to lead and to drive and to push, to respect all those things, but to manipulate them. And people use that word, I'm using it by design, right? It's a very powerful word. People think it's a bad word a lot of times, but the real definition is to control, right? It is to take something where you want it to go. You start manipulating people, yeah, you start going down that bad path. But manipulating this process, controlling this process to an outcome that you want, that's what I'm bringing to the table. That's why I'm there, to control that outcome, not to, ooh, I don't know how we're gonna do that. I mean, if you're gonna go in with that, there's no need to continue. You've already given up. But going in with like, that's cool, that's what you want, I'll be right back. Get out of my way. Without being arrogant. All right?
Last question.
Yeah, no?
Yeah.
I'm not going anywhere.
The,
Plane leaves on Sunday. That's not for me to answer. Like that is, all of you need to answer that for yourselves. I think that they all have benefits. I think that I've spent my entire career in the consulting world. I love it, but I'm extremely comfortable there. That doesn't mean that I'm gonna stay there forever. I think that's in all of us individually. I can't answer that. There are some people that, you know, thinking of some people that I went to school with and after that have stayed in consulting where I thought they'd be in-house by now. Other people that are in-house and they're just flourishing, they love it. So it's up to you. Doesn't matter. You gotta love what you're doing. All right. Anything else?
Well, thank you very much.
Let's call it a night. Thank you. All right.
So students, if you're in the class, make sure you sign the sheet. If you decide to write a paper, that's going to be due by 7 next week, or this coming Thursday. And we'll see you next week.
Leaving.